Hey guys, Mr. Moore here, just going to give you guys a quick rundown on drafting. Yesterday we did a quick drawing. You worked with a Disney artist and did a quick draft on paper, and I wanted to relate some of those things that you did yesterday to what we're going to end up doing. So drafting, of course, is a way of communicating. So engineers need images to give things definition and specific details, and it's a draftsman's job to capture all of those details on paper, things like blueprints. Okay, so there's a lot of different kinds of drawings. I'm going to go through and give you guys some basics. So here we go, introduction to drafting. Okay, first we're going to talk about drafting tools. Okay, you've got a compass. Compasses are used for drawing circles and arcs. Okay, protractor is used for finding and marking angles. Okay, 45-degree and 30-degree right triangles are tools used in developing construction lines and most common lines. These tools eliminate the need for using a protractor to make common angles. They are also marked with standard or metric measurements, sometimes both. And then the T-square. T-square is used to make initial reference lines and in combination with other tools. So you'll use your T-square with your triangle to make certain lines. Okay, you'll always need a sharp pencil. The sharper the better. And you'll always need an eraser. Okay, there are 12 different line types. Okay, the basics are construction line. Okay, this is a thicker or sometimes called an object line. Okay, this is a thicker line that represents an object. So a construction line can also be called a visible line. Okay. The object line is a thick, continuous line that represents all surface boundaries of a print or an object. In print reading, it defines all solid objects and boundaries. Okay, a center line. Center lines are thin lines with a short dash every inch or so. Their function is to define the center of holes, arcs, or symmetry. Okay. Hidden lines. The hidden line is a thin series of short dashes. The function of this line is to show features or lines that are not visible in the current view. This sometimes helps clarify the shape of an object. Okay. Phantom lines. Phantom lines are thin lines with pairs of two short dashes about every inch. Generally, the function of a phantom line is to show motion or alternate positions of a part or feature. So if you're drawing a bike and you want to show that that bike pedal moves to a different position, you can use phantom lines. Okay. Construction lines. Construction lines are layout lines. They are very light lines used to set up the framework for a drawing. So your border, okay, that you put around your paper is a construction line. Okay. Breaks. Short break lines. The short break line is a thick and jagged in shape. The function of the short break line is to break out a section of a part that is too long to show at the existing scale. In other words, it won't fit on your paper, so you use a break line to show the entire object. You just show it in two halves, and you separate those halves by a break line. Okay, we also have a long break line. Okay, long break lines are thin and interrupted by sharp zigzags about every inch. Kind of carries out the same function as a short break. Okay. Then dimension lines. Dimension lines are thin, straight lines with arrowheads, dots, or dashes at the end where they contact extension lines. Also, the actual numerical dimension is broken into the middle of this line or placed above it. So we use dimensional lines to show the dimensions of something or how big it might be, okay, or the distance across it. Right. Leader lines. Leader lines are thin lines with an angular jog or S shape ending with an arrowhead touching the feature. The other end of the leader line ends at a dimension or note. Okay, so a leader line can point to an object, and then we can write on our drawing what the name of that object is. Okay, or we can say this is the center, put a leader line to it, and it shows the viewer where the center is. Okay, we've got cutting planes. Okay, cutting plane lines are thick lines that resemble phantom lines. The difference is that a cutting plane line has arrows at each end that indicate viewing direction. The function of a cutting plane line is to visually carve an internal section out of the drawing or feature. Okay, this is usually done to provide a larger or more readable view. Okay, so it may be exaggerated or blown up a little bit so that the viewer can see that dimension or that specific detail for that section of the drawing. Okay, so you notice that I talked about thickness of the lines. Okay, line thickness and darkness should be in accordance with this chart. So you can kind of see some of these lines are heavier, darker. Okay, the way we accomplish that when drafting is by going over those lines several times. When we start drafting, we actually start with very light, very thin lines, and we go back over and darken those lines for the ones that need to be thicker or heavier. Okay, light lines should be a very light touch initially and increase in pressure once a line is considered permanent. Okay, part of the reason we do our lines very light initially is so that if we want to erase or change something, it is not hard to change. As long as we're using a good eraser, you can change those fairly easily. Okay, this kind of gives you a breakout of what those lines actually look like. Okay, so sectional lines are cutting planes, and it shows a section of the drawing that you're looking at. Leader lines, you can see those leader lines point to different objects or different dimensions. Okay, dimensional lines show us distance between an object. Okay, short break lines, that shows the short break or long break in something. So you can see that block down further at the bottom, near the bottom of the page, shows how something is broken up. Okay, and then phantom lines. Okay, we can show how something moves. Okay, where it might be moved to a different position. So just some examples of some of those lines that we're looking at to give you guys a little bit of a visual. Okay, we're going to talk about scales now. Okay, most of you would call this a ruler, but the difference is this is an architect's ruler or scale. Okay, scale allows us to put a large object on a small piece of paper. Okay, if I told you to draw a house, you could probably draw a pretty simple house on a piece of paper, but if I told you to draw your house, okay, you might find that you don't have enough room on your paper to fit everything as it comes to mind. So what we do is we use scale, we use standard measurements. Okay, we may say that 1/8 of an inch for our drawing equals 1 foot in reality. Okay, so we scale something down so that we can fit it on our page. Angles, okay, we all know there are 360 degrees in a circle, okay, but we rarely think about all of the degrees of angle when we're drawing straight lines. Okay, so we think of the relationship of those lines to one another and how they represent 360 degrees or 180 degrees typically when we're developing a drawing. Okay, oblique drawing. This is a type of drawing. Okay, so you notice a cube there. Okay, we've all probably done this once or twice before. It's very common. Okay, you're going to use your T-square there to set your 45-degree square on and make your initial 45-degree line at the bottom, starting your cube. Okay, and I'll show you guys how to do that. We'll walk through one of these. It's kind of fun. Once you can draw an oblique, then you can draw houses and any kind of object that has square proportions. Okay, this is an isometric drawing. Okay, you'll notice that there are two 30-degree lines meeting at the bottom corner of this camera. The front right corner has two 30-degree lines that help us initiate and start this drawing. It's kind of cool. Okay, and then orthographic drawings. Orthographic drawings show lots of different sides of an object. Okay, and this is important because at times you may need to know more specific detail about the left, right, or front or top side. Okay, we can do up to 8 different orthographic perspectives in a drawing. Okay, so this is what an advanced technical drawing looks like. Okay, so this is a component that shows every detail. Okay, you'll notice there is a isometric drawing there, and then you of course have your dimensions for your different components. Okay, you'll notice that it has different angles. You can see the top, left, right side. Okay, just a lot of different things to look at, but you can develop all of that from one simple drawing. Okay, same with this one. This is actually a large metal hook. Okay, so this hook has lots of details to it. It shows all the angles. Okay, so kind of interesting. It makes you think that many things that are manufactured and designed are not just designed by someone hammering out a piece of metal and calling it a day and saying, well, it looks like a hook, right? No, everything is made and developed to specific details or specifications, and this drawing here captures all those different angles that are used to represent those details. Okay, CAD. CAD stands for Computer Aided Drafting. Okay, you guys may be more familiar with this. In essence, a lot of our movies and things, Pixar movies, Disney, Pixar movies are done in CAD programs. In 1963, a student at MIT developed the first computer drawing program called Sketch. As graphic capabilities became more advanced in the 70s and 80s, programmers saw the need for programs that could show complex images rather than just simple lines and texts. Computers did not yet have the capability of showing high-resolution photos or videos back then. A computer drawing consisted of various lines formed by pixels to represent objects. Okay. Today's CAD, with high-resolution graphics cards and personal computers everywhere, we are able to design at the swipe of a stylus or a touch of a button. Drafting has become not only two-dimensional, but three-dimensional or augmented. Rather than look at a plan for a building, you can do a virtual walkthrough of a building. So obviously technology has really advanced, guys. There's still a need for both. Being able to draw something out and represent it on paper is a great way to be able to communicate. CAD does make things more detailed, but learning to use CAD systems is not always simple. It's like any other computer program. There's a lot of learning involved, and sometimes it's just easier to put something down on paper using pencil and paper. In fact, most designs start out as a paper and pencil concept drawing, and then they are then developed into maybe a two-dimensional CAD drawing or even a three-dimensional object. So lots of fun. We'll get into some of the three-dimensional stuff later on in the year, and that's about it for this introduction to drafting. We'll come back with your next drawing.